Yeah, test 5 covers for this test will be 5.1 through 4.1 through 4.5. Will be the sections covered there. Yeah, we started this unit off with the area, doing the area under the curve. And remember, we did those with rectangles, and so definitely be several questions where you have to do the rectangles. One probably just, you know, using the graph to figure out the rectangles, like if we're going from here to here, say. Yeah, so if I'm using right-hand endpoints or left-hand endpoints, whatever, you know, figuring all that out, finding that area under the curve. And, you know, we say under the curve, but technically it means between the curve and the x-axis. That's, you know, we're approximating the net area. If I'm going from this here to B, what I'm approximating there is the area between the curve and the x-axis. And so in this, my little example here, that would be the area I'm approximating. So it's a net area, for that matter, and it's between the curve and the x-axis. So when we say area under the curve, that's just our shorthand way of saying all that. But that's what it means. And of course, when you have ones above the x-axis, those will be positive, and below you wind up getting negatives because it's all, the heights of those are based on the function value. So anyway, not to go into everything again, but that's what this approximates, because you know, I want you to understand that too. Yeah, so we did some from the graph. We did some from using, you know, a particular function. Right-hand endpoints, left-hand endpoints, midpoints, be able to do all three of those as well. And so we spent, yeah, the first couple of sections there, that's what we were talking about, because when we got around to it, what we were approximating, this area under the curve, that turned out to be the integral, didn't it? So the integral a to b f of x dx is our quote-unquote area under the curve. So that's what the integral represents. You may not have to know that the definition of the integral, but you may, and just to remind you there, you may not have to know it, but it is this. It's f of x of I times delta x if you use right-hand endpoints. That changes, like if you use midpoints, it would be x of I bar. But anyway, what I was going to say was, what I might have you do, we had a couple of problems in our one of our assignments where, yeah, you had to figure out what x of I is. Of course, delta x is b minus a over n. You know that. But yeah, the ones that we did where we had to use this definition, we didn't have to actually evaluate the limit. Just figure out what this would be and this would be, which amounts to, you got to figure out delta x, and then you got to figure out what a term for x of I, and then you can plug that into your function. So anyway, just wanted, I may have one of those. I know I've got one on the review sheet like that, so be sure to review that. Yeah, so we calculated we did the same thing with integrals that we did with these area under the curve, approximated. We approximated integrals using rectangles. We also, if we've got a function like that's a straight lines and that sort of thing, we don't have to approximate it because we know that the area, all we have to do is calculate if I'm going from here to here, let's say that's 0 to 6. The integral 0 to 6 here of f of x dx would just be, we'll calculate this area and this area. Of course, that's a minus area. So, yeah, we could just, calculate the integral by calculating these areas. You take that and minus that. But the other one that kind of different that, from some of them, kind of the same idea, but and the way I phrase these is evaluate this by interpreting it as an area or something like that. That's what I would kind of phrase that question as. So on this one, what you have to realize, like if I was going to do this one by interpreting as an area, you have to realize that if I graph that, y equals the square root of 4 minus x squared, what have I got there? It's a semicircle, isn't it? Radius 2, centered at 0, 0. That's what that is. And so if I go negative 2 to 2, I could change that up a little bit, 0 to 2 or something like that, but yeah, if I, this is that area right there, because they're going from negative 2 to positive 2. And so I'm talking about half of a circle, half of pi r squared, in other words. So this would be half of pi r squared, which is, the radius here is 2, so it would be half of 2 squared, which would be half of 4, which would be 2 pi. Anyway, I wanted to mention that because those are a little different problems that we get to do in these integrals using the antiderivative, but they can be interpreted as areas if they work out nicely, like a semicircle or a triangle or a rectangle, something like that. Anyway, so yeah, approximating integrals using rectangles or interpreting them as areas and calculate them that way. Be sure to do those. And of course then, just our regular, evaluate the integral from a to b or indefinite integral doing the antiderivative. But again, I like to stress that if you've got multiplication, you've got, we do have a couple of options, but the integral, if you have a times b, f of x times g of x, I guess a better way to put it. That, in general, does not equal the integral f of x dx times the integral g of x dx. Same thing with divide. But like I said, you have a couple of options. If you can, go ahead and multiply it out. Yeah. All right. So that's times, but so I can't do it that way. In other words, do the antiderivative of that times the antiderivative of that. But I can get rid of the multiplying by foiling or distributing, or squaring is another one. If I go ahead and fold that out, I can take care of that the problem there of multiplication. What do we got? X to the 5th plus 4x squared minus x cubed minus 4. Yeah, and so now I don't have the multiplication problem that I had. Addition and subtractions in integrals, those are fine. or those are what we like to see. We can do those all day long. You just do the antiderivative of each, and you got it. The other thing I might mention too, if it's an indefinite integral, don't forget the plus c. That is part of the antiderivative there. But yeah, just use your power rule or tree rule or whatever it is. And of course the other option, if we have multiplication and in certain cases other scenarios, yeah, that is multiplication. You got x in both parts of the multiplication. Yeah, you just can't do antiderivative times antiderivative. It makes sense anyway to do that here. The other option though is the u substitution, isn't it? And u is typically the part in parentheses. Get the du, should be 2x and then times dx, and then I like to go ahead and solve for dx. That's what I replace dx by, and that's what I replace that with u. In this case then, the first x, leave it in, but it's going to get canceled out. So it's just 1/2 now, sine of u, isn't it? That's not multiplication, so that's just straight up antiderivative. So yeah, so that reminds us too, remember your trig antiderivatives. Yeah, the thing about these, you are, like here we're doing the derivative of x squared minus 9, and then here we're doing the antiderivative, so you have to keep those straight, which one you're doing. All right, so the antiderivative sign is negative cosine. And then usually on these, we want to go back and plug in what the u value is. Go back to the x squared minus 9 in this case. Yeah, so that's well it. Let me. Oh, the other integral was that we talked about that I might mention here that probably we'll see on the test is our absolute values. And remember those, what you do is you look at breaking it up. In this case, you break it up at the corner. In this case, it's at 3. So split that into 2 integrals then at the 3. So it'd be 0 to 3 and then 3 to 5. And then the other thing is then we replace the absolute value of x minus 3 by either minus of x minus 3 or just plain x minus 3. And one way to look at it, if I graph just y equals x minus 3, we're looking at this graph here. And so this is the part that gets flipped up, and so that's one way to look at it. If the piece, if you're looking at the piece that gets flipped up, then that's the negative part. So this 0 to 3 would be the negative of the x minus 3. And then the 3 to 5 is just regular x minus 3. So. And then you can do those antiderivatives. Think of anything else? I think that's about it. I mean, can't do everything for this, but I think that's about it. If you can do all those, you should be able to